Hello everyone. So we are going through this fundamental things that we should know before we get into C and C++ programming, right? So we have been discussing about like why we need a programming language first of all. Then we understood why we need a compiler. We talked about assembly language, machine codes, and everything. Now we're going to discuss about a very important thing, which is a processor. Okay, so again, why we need a processor? Right, we discussed about smart devices when we discussed about this why we need a programming language. We touched upon this smart devices, right? So even we picked an example, like a person is coming inside a room. Okay, so that room say like it can accommodate around 20-25 persons, and a person is coming in now, and AC is getting turned on automatically. Means it's a smart AC, right? So how this could happen? That could be a sensor inside the room which could be keep measuring the temperature, and when a human gets into a room the temperature is going to be different. So it this sensor will be sending the signal to the air conditioner whenever there is a change in the temperature. So the processor or an electronic chip which has been placed inside the AC will receive the signal from the sensor. It could be a temperature. So it will check what is the temperature now, and if this is the temperature, what I have to do. So this call has to be taken by someone, right? So if this is the temperature, or if this temperature is greater than this, if this temperature is lesser than this, then I have to do this action. So this call has to be taken by someone. That will be taken with the help of processor. So, I mean, processor is not going to take that action. The program that we write will take a call, but whether the temperature is greater than what it's supposed to be, that comparison, that logical operations, that if it could be sometimes an arithmetic operation, like it could take two or three different factors, right? Like a temperature and something else, humidity factor or something, that it could do some arithmetic operations on that, and it could come up to a solution like what it has to do, like whether it just have to turn on the fan or just turn on the chiller as well. Then these kind of things will be decided by our program. But for the program to take a logical or arithmetic decisions, arithmetic calculations, then it it needs a processor. The processor will be doing these things like arithmetic operations or a logical decision making. It all will be done in the processor. Right, so you understood now, right? So we need to take call in the program, right? So to take those calls, we may have to do some arithmetic operations, or we may have to take some logical decisions, and for those things we need someone that is called the processor. Okay, so now we will look into like how processor is doing it. Means like we are saying like it needs it sometimes it may do arithmetic operation or logical decisions, right? So these are the components that will be available in any processor. The two major things, one is control unit, other one is arithmetic logic unit, right? As the name says, arithmetic and logic unit. I think you could connect now why I discussed about those decisions and everything, right? So this is the unit which going to handle all the arithmetic and logic operations that involved in the program that we write. Okay, and the control unit, what it will do, we discussed this. Processor knows only machine codes. It knows only machine codes. You cannot speak in English. You cannot send an English thing to this control unit, I mean to a processor. You can send only zeros and ones to the processor, right? So Every processor will have set of machine codes for set of operations. Say for example, if it is 10, that is equivalent, means like 10 is a binary, so the equivalent of that in decimal is 2, right? 10, 101, what it is, 10 is 2, 11 is 3, 100 is 4, 101 is 5, say something like this, right? So when it is 5, the operation assigned could be like load a data into this memory. If it is 1013, means 101 is 3, right? If it is 3, I'm sorry, it's 5, 11 is 3, right? 10 is 2 and 11 is 3. So if it is 11, then add could be the operation that has been assigned to the processor. So like this, every processor will have some operations assigned to it. So now this command unit, the sorry control unit, is the one which reads that machine code from whatever that we send to this processor, and it will convert that to the respective command that has to be performed. So if this is the command, then it will look for these parameters following that, right? So as of now, you could understand, you know, it is better to understand like a control unit is someone which takes the machine code, and it's, you know, translate that into a command for the processor, and it give it to the other units which supposed to perform those operations. Okay, is the one someone who manages the control instructions which comes inside the processor. Okay, so you know, like we just speaking about, or we are talking about a lot of things like machine codes and everything. So we will just take an example here, and we'll see, no, here is an example. We'll see like how it's been converted from assembly language to a machine language, and from machine language how it's been executed in the processor. Okay, so before that, we just, this is what we discussed, right? um, of course not exactly. So we discussed like what control unit do and what ALU do. What this main memory is? Memory is RAM, the random access memory, right? So this random access memory will have the exe or what are the program that we execute that will get into the main memory. Okay, that exe file is nothing but set of machine codes. Whatever the program that we wrote is compiled to an exe file, or in other words, it's been compiled to a machine code, that is the exe file. So those set of machine codes will be given one by one to this main memory, right? So means it will be there in the main memory. So from the main memory, it will be sent to the control unit one by one. So the control unit will read every instruction which is inside that executable file, and it will send down the directions or send down the commands accordingly. Whatever been the commands there, it will do those operations mentioned in those commands like load or store or add or subtract or multiply. Whatever it's been mentioned there, it will do it. Okay, so the first is like fetch the instruction from the main memory. Second is decode, that will be happen in a control unit. Once it's decode, the respective operations will happen. So if there is any arithmetic and logical decisions is required in that instruction, then it will give it to the ALU, and once the ALU has completed its operation, then it will store it back to the memory. So how it happens, like we will see that now. Okay, so this is the one place where we can see everything, right? One is assembly language, which is on the extreme right. Middle is a machine language, and on the left side it is address, right? So we discussed like what assembly language. Assembly language is, you know, like it is the one which used before the modern programming language came into practice. Means like is much, means it's comparatively easier than the machine language, but it's again very complex to write a huge program just using assembly language, because this nothing but say this load load, add, and store that you can see here is or just a mnemonics, sorry, just a mnemonics for whatever the machine codes are. Okay, that we will discuss now. So what are things that we're going to look into it now, or this address, machine language, and assembly language, right? Like, what is this address? This is the address in the main memory. Here we are seeing the main memory, right? These are the addresses in the main memory. In this address, these things are stored. In the address 0, a 0 is stored. Complete 0 is stored. Means, you know, and in the address 1, a value for ABC is stored. In address 2, value for XYZ is stored. And in address 3, instruction is stored. Address 4, another instruction is stored. And 5, another instruction is stored. Something like that, it's stored. Okay, so these are the address in the RAM. In these addresses, these instructions are stored at the moment. Okay, the instruction 1, it is 00000. Means 0 means like it's just an this section we call it as a code segment, a data segment, right? In the data segment we have the datas that we're going to work on. Okay, so this total is the one which going to get the output. These are the two values that we're going to add at the moment. So this operation is to add two numbers and give the output. So these are the two numbers that we're going to add, and we'll store the output in this total, and we'll give it back to the RAM. I mean, give it back to the program. Okay, so now if you see, right, like these as it is just the data segment, these two, I would say, like, you consider this is 4 bits is shown here, but like consider it as a 1 byte, means 8 bits, but only 4 bits are shown here. So there are 4 bytes. Consider as a 4 bytes, we know that, right? Every byte consists of 8 bits, right? So we'll get into it much when we discuss more about memory, but as of now, the basic fundamental, as you all know, 8 bits is 1 byte. So consider this as a 1 byte and 1 byte and 1 byte. Okay, so the first 2 bytes are not used and the second 2 bytes are used. So this is nothing but the address, not the value. I'm sorry, this is the value and this status, right? So this is the value of that particular, the data that has been getting pointed. Say this is the address, and at this address at the moment value 0 is stored, there is no value. And this is the address 1. In the address 1, value 2 is stored, which is the binary version of the 2 is 10. And in the address 3, I'm sorry, in the address, yeah, it's 0, 1 and 2. In the address 2, value 3 is stored. The binary format for that is 1 1, right? So this indicates nothing. These, I mean, first 2 bytes is indicates nothing as of now, but these two are indicating the value of that data which is getting stored over there, stored in this address. So in this address value 2 is stored, in this address the value 3 is stored. Okay, now coming into the instructions, the first byte talks about the machine code. I mean, the code which corresponds to an operation or a command for the processor. So if you see load, whenever we say load, the byte indicates value 1. So if it is 1, then it is a load operation for this processor. If it is 5, then it is add operation. If it is 2, then it is store operation, right? So this is how it has been. So the first byte indicates the machine code, and the second byte, if you see the second byte, it indicates the register that it's going to use, and the remaining bytes is to store the address of the value that it's going to copy from. So the load operation is about load whatever the value inside this particular address, mean address of ABC, into the address of into the register D. load whatever the value in the address of XYZ into the register E, right? So that is what is happening. So this indicates as soon as the control unit reads this 001, it says it's going to do a load. Then it will next look for what is the register address. It will say 1101. If it is 1101, then it is register D. So from where I have to load a value? I have to load a value from the address 000001. What is the address 000001? What is there in the 00001? 2 is there, right? So it's going to load whatever the value in the address 00001 into this register, which is 1101. The register 1101 is nothing but register D. And in the next instruction, again load, it's going to look what is the value in 000010. What is the value in 00010? It is value 3, right? So it will load that value 3 into this register, which is 1110. What is the register here? It is register E. So it loads the value 3 into the register 3. Already loaded the value 2 into the register D, right? Now it has to, it's doing another instruction now. So what is that? 0101. So it means add. So it's going to add. As soon as the control unit read it is an add command, what it will look for 3 registers now. The one register is to store the result, and other 2 registers will have the values that it has to add, right? This register is 1111, means the register F, okay, and it gets 2 registers. One is registered D and register E, which is 1101 is register D and 1110 is register E. Okay, it takes 2 values from the register D and E and it adds and it stores the result to register F. Then now it's inside the processor. So whatever the register that we are discussing here are inside the processor. These are the registers. You see that these are registers. These are the registers that we are talking about. D, E, everything is inside the processor. Okay, now we calculated and got the output. Now we have to give it back to the memory, right? We have to give it back to the RAM. So this address, which is in the RAM 00000 is in the RAM. So we are storing the value that we got as a result of adding the values in D and E into the total, and the program get halt. This is what exact way this the whole programming works. The programming will convert it to assembly language. Whatever that we write using our modern programming language will convert it into assembly language. Then it will convert it to a machine language. Then it will be fed into the processor. So these, whatever the instruction that we converts will be stored in these addresses, and the control unit will get instructions one by one, and it will send to arithmetic and logic unit for the calculations, and it will perform the calculations and it will store the result into the main memory. So this is what exactly the processor is doing for a programming. Hope you all understood, and if you have any questions, please put it in the comment section. And thanks for listening again, and we will come up with another thing that we should know before we get into the programming actually. Okay, see you then, bye.